Okay, so again, today we're going to be talking about MailPilot. MailPilot. This is the main lesson. Like I said, you're going to build upon this one for assignment number 4. And it comes right out of that book that we used to use for the course, which is kind of cool. The Outline to Learning, and big props to the author because he was the one that kind of came up with this. And he's a professor, and you can find him, Andy. You can find him up online as well. And he's got his own videos that you can download if you know where to find them. And he goes through each of these steps that I'm going to kind of show you for these lessons. So this is lesson 7, and it's like it kind of goes in line with the chapters of the book when it was produced. But again, you could use the online stuff that I've kind of shared with you, those links, those online links that exist for the other books that exist. Okay. So really what we're going to do with this lesson is we're going to talk about how to plan a game, right? We're going to talk about more complex projects. And I think we've talked about this with other professors. We've kind of, we're discussing, well, how come these students, they really don't, use the project management fundamentals? And I think part of the reason is because a lot of you guys can do it in your head, right? The projects are so small. You sit there and you go, well, I can figure this out. I don't need to do much planning because, it's in my head. I know where I'm going with it. But when you get to more complex stuff, you really do need to plan. You need to kind of put up some milestones and so on. And this is why I encourage you to use GitHub for your milestones, so that way you can preserve the work that you're doing. So we're going to talk about sprites a little bit more. We talked about intro to sprites last week in lesson 6, and in lesson 7 we're going to talk a lot more about sprites than we did last lesson. Okay, so here's the goal, to build a complete game. So we're going to be doing, let's say, equivalent of assignment number 4, except for assignment number 4 we talked about last week is going to be a side scroller. This is going to be a top-down scroller. So really you have most of the code here that I'm going to give you. All you got to do is turn it to the side and meet some of the requirements that I asked for. Okay, so you're going to have an instruction screen. You're going to have an avatar. So it could be, in this particular case, it's going to be a plane. Okay. You're going to have opponents and goals, right? You're going to have a scrolling background. We're going to talk about that. Scorekeeping, which we're going to see as well. So let's take a look at MailPilot again as our templates. So if we go to Aptana again, and we look at the Lesson 7 archive online on Blackboard, and we actually look at mailpilot.py, okay, this is the code that we're going to build up to, okay? So let's wait till this thing loads. And I encourage you to follow along with me, so I would launch Aptana as well and take a look at this, the stuff we're going to be building. So one of the things that I want you to notice off the top is that we're using classes. So if you haven't had a chance to work with classes until now, or you've been avoiding them because you don't like them, I would encourage you again to take a look at your object-oriented programming again and start thinking about them. So if we run the code, and you're not going to hear any sound again because it's going to pipe through my earpiece, but let me just run it for you. So here it is. So here's your scrolling background. This is your start screen. Okay. The scrolling background, we're going to look at that in a bit. But if you notice, it's just going to continue to scroll south, right? So it goes from the top of your screen to the bottom of your screen and continues scrolling down, right? Okay. And then you have this instruction stuff, and these instructions are just a font that's actually a sprite that's been posted. You've got your last score is 0, so you actually have a score as well, and it's looking to click to start the game. So I start the game. I have my plane, and I use my mouse to control my plane. And if you notice, my clouds are my enemies. So as I move through the clouds, if I hover over an island, I got some points. Here's some more points, right? Now you can't hear the sound, but it's going yay, yay, yay from my ear. And then whenever I crash into a cloud, it goes kaboom. There it goes. Okay, and if I have too many crashes, then I lose, and I've got my last score. So my last score is 700. Okay, so I click it again. Now, if I click it again, I automatically start again. So here I go. Yay. Right? I avoid it. Okay. This is MailPilot. So it's all the components almost that you need, almost all the components you need to finish off your side scroller, but you got to make everything go in different directions, which means you have to understand how this goes south, if you will, 300 points. Okay, if I press escape, or if I press the X on the top here, it stops the game. So it's your template. Okay, and again, we're going to go into detail as we build this this game from the bottom up. So we're going to build all the component pieces in this lesson. That's why this lesson is, like I said, probably the most important lesson for this session anyway. Okay? I mean, it's almost like this is the assimilation lesson, where you kind of take together all your Python knowledge and put everything together to create your first top-down scroller. Okay? With all the components like sound, sprites, scoring, and everything. Okay? So, again, I think this is reasonable stuff that it's saying here in our presentation. You need a bunch of requirements, or your essentials, if you will, when you're designing your game. You need your environment. In this particular case, the environment is the ocean and the clouds. All right, the plane is flying. That's the environment. That's your game world. Right? What are the goals of the game? For MailPilot, the goals of the game is you're supposed to fly over an island. So when your plane actually flies over the other sprite, so your avatar flies over the island sprite, and they connect. There's an intersection, right? What ends up happening is you gain points because you were successfully able to make a mail drop. Now, there is no animation to show the mail drop happening or anything like that, but that's what essentially is supposed to happen. Okay? So that's one of your goals. The other goal is, or one of the obstacles are the clouds. The clouds are going to be randomly placed on the screen. They're pretty big, right? So it's going to be tough to avoid them. And as they scroll down the screen along with the scrolling background, it's going to give the illusion that you're flying. But at the same time, if you go into a cloud, you got this explosion happening because the plane somehow can't fly into clouds. Okay? That's really the game, right? It says appropriate difficulty for the user. And you'll see, because of the way the sprites are, and we talked about sprites last week, how you have a bounding box around the sprite. It's not easy. It looks like the plane can fit through the clouds sometimes, but sometimes they can't because the bounding boxes are going to touch, and you're going to see a collision, right? So these are kind of things you could fix with your game, right? There's some art and music assets. Artwork, so multimedia assets we're talking about here. I said, hey, it's okay for you guys to get your assets from the internet. It's okay, right? And again, we're not going to be reselling this stuff, so it's not, from a permission perspective, it's not like I need to ask permission for somebody right now from an educational point of view. But theoretically, if you're going to make your own game, even for yourself, you should try and create your own graphics. And it's not that difficult to do if you try. Reasonable scope of programming challenge. And I think, you know what, MailPilot is an example of a reasonable scope. It's like 4 or 5 iterations, right, that you're going to do with one assignment or one project, and you're going to be able to finish your programming challenge, okay? What this means is, again, I said it before, don't write yourself into a hole. Don't create a black hole that's going to suck all life out of you, right? Because you can do that. Like, for example, some of you creative types, and I'm pointing at, some of the creative types that we know in the room, right? They may love to be creative, right? And it's great because these creative types, you need I think the full brain when you have a team, right? So if you have a creative type in your team and she or he is really pushing for some really cool stuff, right? It's great because you're going to be able to push the envelope, make a new original game. But on the downside, you got to have someone to manacle her a little bit, right? Or him. Chain him down, right? And say, no, you can't do all this stuff. You've got to exclude this from the scope of your game or you're never going to bloody finish, right? At the end of the day, right? So you got to kind of make it so what's doable? And you got to reasonably say this is doable and this isn't. And if we have time, we're going to add this. That's what you need to do. So that's where the planning and all that comes into play. And it's really, really important. Okay. A game sketch. Now they're going to show us here a game sketch, a way of doing things. I encourage you to do your own sketches, just like we do an interface sketch for whether we were doing the slot machine, or if you've been with me in other courses, I always encourage you to do some kind of wireframe I think it's super important for you to be able to do a sketch of your user interface at the very minimum, right? And I think for a game, even more so, sometimes what you need to do is create your storyboard, right? Now, I'm not going to teach storyboards in the course, but really what you want to do is almost kind of create an arc, a story arc that goes from one game screen to the next, right? It's almost like a user click-through, if you will. So let's say if you're creating an interface for an application, you want to kind of create a click-through for your user to say, here's all the different clicking and options and interaction that you can have for the user, and create these paths that the user can take, that you're going to sketch out for yourself, right? The more thoroughly you sketch out these paths that the user can take, the better your game is going to, or your application, the more robust it's going to be in terms of breaking. And from a debug perspective, you're going to know what the expected results are. You're going to say, well, here are the expected results, but here's what I'm getting, and why am I getting these, these unexpected results, right? So again, a game sketch is kind of one of the pieces of our plan, okay? I like what it says here, label everything. I think that's important. When you make your game sketch or any kind of interface sketch, label everything. Put all the labels where you need them and describe the key features that you're going to have for your object, whether it's an avatar or whether it's an interface or whatever you're doing. I think it's important when you create your game sketch to be as thorough and as detailed as you can, right? Plan for sound effects. I think it's really cool. If you plan for sound effects, you might say, from a storyboard perspective, you might say something like sound effect, boom, whatever. Like if you show the collision, you might, when you create multiple sketches, you might show, well, here's, the main game screen when it starts off, and then here's a collision with my player and my player's avatar with his enemy or a bullet. Okay, well, there's a boom. There's going to be some kind of, you're going to plan for the sound. And some people, almost like a comic book, you see like a bubble and you go boom with it. It's important to kind of outline where the sounds are going to be, so when you start sketching your game, and if you're not the programmer, you're part of the project team when you're making the game, or the art director, you know where you want these elements to be, right? Scorekeeping. How do you get to the game end? How do you end the game? How do you win? Right? I think it's really important. Some games, especially nowadays on the iPad, I'm not sure if you guys have downloaded these new games, but there's no way of winning. You make a game and it's a hair cutting game, Person cuts the hair. Like my daughter loves to do this kind of stuff. She downloads this hair cutting game, and there's no winning. There's no points. You just haircut, right? And it's okay. It's kind of cool for a baby to play with or whatever, right? Or even a little girl. But after a point, it gets boring. You've already cut all the hair, right? Yeah. Well, there's no point. There's nothing that's going to make it challenge you to improve, right? So it's important from scorekeeping has always been something that we use as, hey, I'm going to get better and better at it. I'm going to get a higher and higher score, right? So I think from a challenge perspective, it kind of adds in that extra feedback to the user that they did well or they didn't do so well, right? So, and that's why I've asked for assignment number 4 to include scoring. So here's an example sketch. I'm just going to maximize this thing for you guys to see. An example, all right? So you've got your mail pilot plan. Here it is, right? You've got your cloud, right? Your island. You've got planes, all kinds of other different things here. And you're starting to describe, through this whole process, you're describing, what each of the elements are. So let's go through it step by step. So 1 is your plane, if you notice, right? And it says the mouse controls the side-to-side motion, right? Plane stays constant in Y, but scrolling background elements give illusion of forward motion. So remember, there is no real forward motion here. The plane is actually staying stable on the screen. It's not actually flying, right? The background is giving the illusion of the motion, right? So let's go to number 2. Okay. The tiled ocean background moves downward for the illusion of forward motion, and it goes at a constant speed. And it's the same as the island. So the speed of the ocean is the same as the island, all right? So again, this describes the elements of the game. And if you read this, it actually kind of just, looks at your game screen itself. It's not actually a the game screen and how it looks, but it describes elements of the game. And if you notice, it even have things like sound effects, engine noise, the cloud plane collision, the island plane collision, all that's mentioned here in the game sketch. You can take this one step further, like I said, and really clean it up so it looks closer to your interface, right? And I like how they label things here, but what I'd rather do is actually create as close to what the game is going to look like with your interface sketch as possible. I think it's even better. This is like all in one. He packed everything into one sketch, right? Okay. And this is the key learning here, that I want you guys to take away from today's lesson. Stepwise refinement, right? In other words, you have these milestones for your development, right? You sit there and you say, okay, I'm going to start off with creating the plane's motion, left and right. That's all that's going to happen. I'm going to do that part first. Okay, it works. Move on to the next part. I want to talk about the clouds. The clouds are going to start moving, or whatever. And then you keep on working on one part at a time until you've got all the piece parts that you need for your interface to work. But you make sure that each of the individual parts works before you move on to the next piece. Okay? So here's some milestones for your mail pilot, an example, right? And this is, by the way, all these piece parts and all this code, the example code's up on Blackboard, right? So you have your basic plane sprite. That's the first thing that they're going to do. You're going to do your island sprite. You're going to put your cloud sprite together. You can do collisions and sound effects. These are all the different milestones. Scrolling ocean background, multiple clouds, scorekeeping, your intro screen, and then finally you have your entire game from all this stuff, right? So these are all your milestones that we're talking about here. And sometimes they're doing them in they're separate pieces that they haven't amalgamated or assimilated into one program, as you'll see. So again, let's build your basic airplane. The first piece is your airplane, okay, your plane sprite, if you will. So what you're doing is you're having this class that you're defining as a plane, right? My plane is my new class I'm defining. It's a subclass, like we talked about before, last week and the week before that, of the Sprite class that's part of the Pygame framework, okay? In your constructor, which is this part here, where it says init, right? Here's your constructor. You're actually going to also include the sprites, the parent Sprite class constructor as well, okay? You're going to have to call this parent constructor. Here's your self.image, right? And you're going to load your plane sprite from this, in this particular case, it's loading up from the same folder as this file. So let's say, for example, this file is called plane.py, right? Then plane.py and plane.gif got to be in the same folder as is defined here. Otherwise, you'd have to give the exact folder location of your image. In this particular case, the image is a GIF file, but you're also able to use ping files and bitmap files as well with Pygame. Okay? And then what we're doing is saying, well, self.rekt, right, is equal to the image, right? I'm taking my image sprite here, and I'm applying the GetRekt method on top of my image. Okay, so how does this work, right? And again, I'm going to try and do this for the first time. Let's just bring up something like fireworks. And again, I encourage you, as I'm taking this really slow today for a couple reasons, because I really want you to understand how we're going to build, and we're going to do this stepwise refinement as we move forward. Okay, so here's again fireworks. And by the way, as you know, Adobe's coming up with their Creative Cloud stuff now, which I kind of like and I kind of don't like, because you got to subscribe to it every month, which is kind of a bad thing. It's not like you can have your desktop apps and you pay for it once. It's like you pay for it always. So it's kind of a negative for me. I don't like that. But that's just my opinion. Okay, so I want to load up my plane sprite. So here I'm going to find where my plane sprite is. And in this particular case, I'm going to go to lesson number 7 in my code archive. And I'm going to look at my, these are all my assets. So there's a couple of assets I have here. One is a ping file, and the other one is the GIF file that I'm loading up. So let's load up this GIF file. And this, for these creative types, I think this is something you might want to enjoy looking at. So here it is. I'm loading it up. right? And it's pretty small, so I'm going to kind of zoom in here so you can see it. There's the plane sprite. This is what my sprite is going to look like, right? And if you notice on the actual sprite itself, right, the background of the plane sprite is actually blank, right? It's actually there is no background. It's been removed, right? Now because it's a GIF, it's going to fill in the background with white. That's the default color that it's going to fill it in with. Okay, but let's just leave it like this for now. Okay. The other thing is when you use that GetRekt method. So let's just go back to my presentation here, right? So self.rekt, I'm defining a new variable called rekt, right? Rectangle, right? If you will. And I'm using the self.image object that we've created up here. We've loaded in, right? And I'm applying the GetRekt method to define a border. So where's the border, creative types, around the plane? I'll see if Haley can get this one. Haley. Hi. Actually, you're actually live. You're being recorded here. Where's the border around the plane? Where would if the GetRekt function actually looks at the plane itself, where would it draw the border? It's pretty simple. Around the square, right? And the reason why I'm asking you to concentrate and look at this is because this is the key thing about sprites. And if you miss this part, you're not going to get it. So really what it's going to do, it's imagine if I was going to take an object like this is what Pygame actually does. And it says, okay, I'm going to define a border around the plane. Okay, let's make it transparent. Okay, and let's put in a border width of, I'm going to define my pencil as black, let's say, for this particular case. This is a pixel width of 1. Okay, it's actually not like this, but imagine that there's a border around the plane like this. Okay, and it's a pixel width of 1. That means that if you notice part of the plane, right, this part here, right, that I'm in this lower half, if another object comes into contact with this part of the plane there's nothing there, there's no plane drawing there, right, it will have a collision. A collision will occur, right? So this is where the border of the plane will come into play when I use this function, GetRekt, right here. Okay, that's what it does. So it's not the most efficient function when it comes to sprite collisions. There are others, like I mentioned last week, up on pygame.org, right, that you can look at that work a little differently than this. You can also reduce the border ratio, right, so that it's smaller than the actual plane itself. Or you can actually match it pixel by pixel. There's advantages and disadvantages to both approaches, right? So that's the first thing that this does. The other thing it does is that we create in our plane sprite, we're going to create this update. And remember, the update is what we're going to use our all sprites group, or our group. We're going to group or compress all of our sprites into a big list of other sprites, and we're going to update all at once, all together. Okay? And what we're doing here is we're saying my position of the x and y coordinates of my plane, right? I'm actually going to get them from this mouse.getPosition method, right? So I'm going to say, wherever my mouse is, I want to take the x and y coordinates. And if you notice, this method spits out two variables, mouse x and mouse y. So it could be whatever you want to call them. In this particular case, the author has called it x and y, right? And then here, what we're doing is the center of the rectangle is going to be mouse x. And we don't care about mouse y. We're actually discarding that information. We don't care where on the screen, up high or low, your mouse is going to be. All we care about is your left and right motion. If we translate this in for assignment number 4, we would reverse this kind of stuff, because all we care about in assignment number 4 is your upward and downward motion. We don't really care about left and right necessarily, right? If you limit yourself in assignment number 4, let's go back to fireworks. Okay, and I'm going to define a new surface object. Let's say my screen width, the size of my screen is going to be 640 by 480. So here's my screen, right? And now what we're doing is, as an example, we've got an object. I'm going to take my plane object here. I'm going to just remove the borders just to make it look like it is. So here's my plane, and here I'm putting it on my screen, right? So here's my screen, typically for MailPilot. And what I'm doing here is all I'm allowing it to do is go right and left, right and left, right and left for the plane, right? But for my assignment number 4, maybe what I want to do is take this object or something like it. And obviously I'm going to point it in the direction that I want it to go in. So I'm going to point it this way now, right? And now all I want to do is go up and down, because the screen is going to come this way, right, for the right. Now that sounds funny that I'm telling you just to rotate the object. I mean, that's what you could do. I'm asking you not to use MailPilot resources, assets. Don't use MailPilot and hand it back to me for assignment number 4. You'll get 0. I'll tell you right now, right? But you could do this. Or if you're scrolling in the other direction, right, and again, I'm just, I'll rotate it the other way. So here it is. So if you're scrolling from a left to right perspective, depending on what your game is going to be like, you can choose whichever way you scroll. It's going to maybe go up and down. Here's a bad thing to do. This is bad. If you were allowing it to go up and down with your mouse, the bad thing is it's really not realistic, right? If I can go this way up and down and kind of follow my mouse around, it doesn't look realistic from a plane perspective. And I've had students in the past do that. So my recommendation for you to get full marks for assignment number 4 is limit your forward and backward motion. Okay? So either make it so that you can only move forward and backward a little bit, or nothing. Right? And then only up and down. Only up and down like that. That would make it more realistic from a side-scrolling perspective. Right? So, do you have a question? Oh, no. I want you to use mouse input for a reason. Yeah, there's a reason. Yes, key input would make it even easier. Right? The challenge is with key input, you're going to have to listen for a continuous stream of key input, which is a different thing we have to talk about later on. There are ways of doing it, because all you're listening for is, you can actually listen for continuous input from the keyboard, right? So if you press the button, it's going to keep firing, right? Okay, but this is the way to do it. So I'm asking you to go up and down and limit your movement of your plane, and which would make more sense if this is your screen. Now I've defined a surface area of 640 by 480, but you can choose to make your screen the size that's appropriate for you. So if you're designing for a phone, right, as an example, and I'm going to move this to the middle so I don't lose it, and let's say you want to do 320 by 480 rotated on the side, right? Let's redefine our canvas, right? So it's going to be 480 wide by 320 high. This is a typical iPhone or a smartphone, right? Now it's pretty big. In this particular case, my avatar is quite large, right, for my iPhone, right? But again, you limit your motion to this. That's all you do, right? Because if you did any of this stuff and you're able to move it around, it would look really funny. Trust me, if you start planning it like this, and if it's this big, it's bad. So again, I would probably reduce the size of my object. And again, you can do that by just testing it out. So let's say here's my plane now. I've made it even smaller, right? And now it makes more sense for my iPhone, right? And you'd probably be doing this with some kind of controls on your phone, up and down, right? Okay, let's go back. So really, that's what this thing does. That's what this piece does. All we're doing here is focusing on my avatar, the plane, and we're moving it up and down, or side to side. That's what we're doing with this class. I love it. All right, so let's take a look at MP plane, so MailPilotPlane.py, to see this stage. And again, I'm going to take you guys through it that slow, right, because I want you to see each stage of the development. So here's MPPlane.py, okay? And again, it's exactly what we show in the PowerPoint presentation. Here's the plane, right? And all we have here for the rest of it is the screen is going to be 640 by 480. Right? My background, it's going to be the size of my top level window, right? We're going to fill it with blue. Here's a blue background because we're going to kind of try and simulate the blue ocean eventually, which is going to go there, the blue ocean sprites. We're going to make it blue. We're going to blit the background onto the screen. So we're going to display the background onto the screen. We're going to link it to its parent, right? And then we're going to instantiate the plane sprite. Here's the plane sprite. We're going to instantiate with our plane class, okay? We're going to put it into a group, all sprites, and we're going to include just the plane in that group. It's good practice to start building your group up before you actually have more than one object, like if you have multiple plane sprites. You're going to define your clock. Here's your clock. And you're going to define your frames per second as 30 frames per second. So here's the amount of frames that we're going to do. We're going to do this many checks every time we're going through our loop. So we're going to check 30 times a second for updates, right? We're going to set our mouse visibility to false. We're going to take away our mouse pointer because we don't want to see the mouse pointer when we're playing our game. We want to see our plane, right, moving around. We're going to listen for our all the events here with Pygame event get. So we're listening for all the events. And specifically, we're saying if we hear the quit event, we're going to our keep going is going to be false. We're going to stop. We're going to exit out of our game loop. And then we're going to perform on the sprite group a clear, an update, and a draw. We're going to redraw the sprite back onto the screen every frame. And we're going to display flip. We're going to use the buffering built into Pygame to display the object back onto the screen. When we're done everything, we're going to return the mouse visibility to true. Okay, that's really the heart of our code. And if you notice, this is the same code that we used last week when we were moving around sprites on the screen. So there's nothing special here about this code. Okay, so let's take a look. So again, we have no sound. We have nothing. All we have is the plane moving around left and right. And if you notice, I would encourage you to try this on your Aptana Studio so you can see that your motion is limited. Your plane can't go up and down. All it can go is left and right here. Okay? So here's left and right motion. So we've got that going. So now this piece, right, is our first piece, our avatar, actually scrolls left and right. If we were going to change this for our, like I said, our side scroller, right, we'd want our avatar to look different, obviously. It'd have to look towards one way or the other. And like I showed you earlier in Fireworks, and we want to limit it the other way. So let's do that as a practice. So let's say, for example, instead of mouse X to be limited, and right now we're limiting mouse Y to 430. Well, I want to limit mouse X. And let's say we want to limit mouse X to, I'm just coming up with this number here, 150. So I want to limit mouse X to 150. And all I care about here is mouse Y. So here's my mouse Y, right? Now my sprite's not going to look proper because my sprite's, it's made for upwards motion, not side to side. But let's take a look at that. Right? So now, look, here's 150, and I can't go left and right. All I can go is up and down. Right? And that might be something that you may want to try and do. Okay? Again, the plane has to be pointing in the right direction. Right now it's not. Okay? So the blank background of the plane, the GIF image, has all the information of it. And again, going back to Fireworks, all the information of it removed. So here's our original plane image. So there is no background here. I don't have a background color. There is no color, right? And depending on the kind of GIF, in this particular case, Python and Pygame will look at this image and say, I don't have any information here, so I don't have to remove anything from my sprite. Okay? It's transparent already. But this is the kind of plane I want, right? I want it up and down, and I want it to point this way. So I'd have to save another kind of image. Let's do that. Let's create another sprite. Okay? So I'm going to rotate my plane if I want my plane to work, and I want it to go in this direction. So, and by the way, if I use Shift, I can it'll limit the amount of rotation for Fireworks. Fireworks has that capability. A lot of the Adobe products do. And I'm going to use my Canvas Fit Canvas option to change this my plane so it only it fits inside the canvas. Now I'm going to use my Trim Canvas command to trim my image so it's smaller. So this is my actual image of my plane. I'm also going to flatten or group my selection. So here's group. And I'm going to flatten my selection so that way it's only saving the image that I want. Because if you notice, there's some other information out here. And I really don't want the other information to be there. All I want it to be is this image right here. So this is my new plane. All right, I'm going to save this. Okay, I'm going to save it in the same directory because I want to use this plane. I'm going to call it, a plane 2, just to make it something that's unimaginative for you guys. For the creative types, you probably call it something like side plane. Okay, I'll call it side plane. Side plane. Okay, here it is. I've saved it. And now what I need to do, and I encourage you to try to do this on your own as well, modify this information. So I'm building assignment number 4 for you right now. Okay, here's how we're doing it. Okay, and I'm using MailPilot assets, obviously. One thing I need to do here is I need to change my plane to sideplane.gif. Oops. So my plane asset has to change. So here it is. And now when I run it, as long as I've done everything correctly, here it is. My plane now is up and down. I've changed the way my plane looks because I physically changed the sprite to actually rotate. Now I could use rotation and translation functions built into Pygame to do this as well. If instead of me physically changing my sprite asset, I could use my translation in Pygame to rotate it to the right. But in this particular case, I don't. Now I don't like where it's positioned because I think 150 is too much. So let's scale it back a little bit because I think 150 is wrong. Maybe I only need it to be 75. Let's say maybe that'd be enough. Let's take a look. So 75 is probably more like it. So there's my plane. Now I'm able to scroll up and down. There is another problem, however. The other problem is I'm able to go all the way down to the bottom of my screen. Now I don't know if I want this as a side effect. Maybe I only want my plane to go here, right? And then maybe I don't want my plane to go on the top or past the top. So allow my plane to slink off past the screen. So I need to figure that out, right? Maybe I don't want this motion to continue going up and down. That's another story, though. We have to kind of figure out. I want to limit my motion of my plane, right? And I can figure that out by actually seeing that I'm going to get my mouse X and mouse Y function. Here's my mouse X and mouse Y. And I can put in another if statement in here saying, in my update saying, if the mouse Y is going to be greater than or less than the screen size, I can change the screen size to whatever my plane is, so it'll buffer on top of the screen. It'll actually push the plane down, right? So the center X and center Y, if it's a certain location, it can't go beyond that location. It'll limit my plane even more, and that's where I would put it right in here. And I would play with this number until it looks right. So it doesn't bounce my plane back on. Because if I put it wrong, like for example, if I say if, and I care about mouse X and Y now, if mouse Y, as an example, is greater than the screen width, right? So let's say the height of my screen is 480, right? Then, right, well, I want mouse Y, and I don't know the size of my plane. I'd have to know the size of my plane, so let's take a look. I'm going to go back to fireworks, sorry. Here's what I could do. I know the height of my plane is 60, right? So from the center of my plane to the outside of my plane is 30 pixels, right? So I know there's a 30 pixel play that I have either one way or the other, right? So what I'm going to do, I'm going back to my code, if I know it's 30 pixels, I'm going to say, look, if mouse Y is greater than 450, right, as an example, 450, not 480, right? If it's greater than 450, well then I want mouse Y to equal 450, right? So it can never really go beyond that, right? Make sense? So that'll limit the bottom part of my thing there. And the same thing goes with the other command, which would be, or the other check that I have to make is the top, right? Actually, let's put the top of the top, just to be more structures. If mouse Y, right, is less than 30, right, well then mouse Y is equal to 30. Okay? So if that works, and this is going to happen on my check, I'm going to change my position. It shouldn't allow me to move my mouse at the top, beyond the top or the bottom of the screen. Let's try that. Theoretically. We won't know. Oh, see? I can't move physically beyond the screen. So it actually limits me even more. Do you understand? I've created a border for my mouse. I'm saying my mouse can't move my avatar beyond the limitations of my screen width. I don't want that to happen, right? Okay, let's pause there before we move on to the next part. I just wanted to show you this piece as if we're building our MailPilot side scroller as we go. Okay.